Hello viewers, in today's session we are going to discuss another important problem from differential equations, right? And here we are given a differential equation x dy is equal to y times dx plus y dy, and we have to find a y of minus 8 if y of 1 is equal to 1 is given, right? So here one condition is given, that is when x is equal to 1, y is equal to 1, this is given, and we have to find the value of y when x is equal to minus 8, right? So what we will do, we'll first find out the solution of this differential equation, implying that we have to solve this differential equation, and then we can find out the form of the function, that is y of x, and then by applying this condition y of 1 is equal to 1, we can find out the constant of integration, and then we can easily find out the value of y of minus 8, right? So let us first see the solution of this differential equation. So to solve this differential equation, let us rearrange the terms. So here we can write x dy, and multiplying these two terms by y, we have y dx, and then we have here a y square dy, right? Now taking this term to this side, we can write x dy minus y dx is equal to y square dy, and now multiplying both sides by minus 1, we can write minus x dy plus y dx is equal to minus y square dy, and then we can write y dx minus x dy over this term, that is y square, and here we have minus dy, right? So what we have done here, we have arranged this differential equation like this, right? And here this is an important term, right? So here if we closely observe this term, then we can easily see that this term is the derivative of um, that is x over y, right? So this entire term uh, is the derivative of the term that is x over y. So here we have y dx minus x dy over y square, because see, if we apply the quotient rule, that is du over v, then we have v, then here we have du, and then we have u dv over v square, right? So this is an important result which is used over here. So here x is u and v is y. So we have applied the quotient rule for differentiation of x over y, right? So the differential of x over y is given by this term. So we can now replace this term by d of x over y. So now we can write d of x over y is equal to minus dy, right? And integrating both sides, we have d over x over y, and here we have minus integral of dy, and c is the constant of integration, right? So the integral of d of x over y is simply x over y, and here we have the integral of dy as y, so we have minus y, and here c is the constant of integration, right? So now we can write x is equal to minus y square plus cy, right? So this is the general solution of this differential equation containing the arbitrary constant c. So now to get the value of this arbitrary constant c, we can make use of this initial condition, that is y of 1 is equal to 1. So when x is equal to 1, we have y is equal to 1. So substituting these values over here, we have 1, then we have minus 1 square, and here we have c times 1. So this is 1 is equal to minus 1 plus c. So c is equal to 1 plus 1, that is 2. Right? So the value of this constant of integration is equal to 2 for these values. Right? So now substituting c is equal to 2 over here, we have x is equal to minus y square plus 2y. So now our aim is to find out the value of y of minus 8. So what we will do, will proceed from this expression. So we have here y square minus 2y plus x is equal to 0. Right? So this is a quadratic equation in y, and to get the value of y is equal to minus 8, what we will do, will take x is equal to minus 8 in this expression. Right? So what we have y square minus 2y, and here x is minus 8. So this is equal to 0. So now we have a simple quadratic equation which can be solved easily by a method of splitting the middle term. So we have the two numbers, that is 4 and minus 4 and 2. So we have minus 4y, and here we have 2y minus 8 is equal to 0. So taking or grouping these two terms, so we have y, then we have y minus 4. Here we have 2y minus 4 is equal to 0. So this is y minus 4 times y plus 2 is equal to 0. So we have y is equal to 4, and from here we have y is equal to minus 2. Right? So for x is equal to minus 8, we have two values of y, that is minus 2 and 4. So we can write y of minus 8 is equal to either minus 2 or 4. Right? So this is how we can solve these type of problems. So viewers, here let us discuss an interesting analysis of this quadratic equation. Right? Now see, if we apply the quadratic formula to this equation, that is y square minus 2y plus x is equal to 0, let us see what we get. Now if we compare this quadratic equation with the standard form of the equation, ay square plus by plus c is equal to 0, then a is 1, here we have 1, and b is minus 2, and c is equal to x. So let us find out the discriminant of this quadratic equation. We have b square minus 4ac. So here we have minus 2 square minus 4 times 1 times x. So this is 4 minus 4x. So we can take 4 outside. So we have 1 minus x. Now the quadratic formula, it goes like this. So here we have y. So we can write y is equal to minus b plus minus square root of d over 2a. So now substituting the values, here we have minus b, and minus b is 2. So this is 2, this is plus minus square root of 4 times 1 minus x, and here we have 2 times 1. Right? So this is y is equal to 2 plus minus, here the square root of 4 is 2. So we have 2 times square root of 1 minus x over 2. right? Now taking 2 common here, we can now write 2 times 1 plus minus square root of 1 minus x over 2. So 2 and 2 get cancelled, so we are left with y is equal to 1 plus minus square root of 1 minus x, right? So here we can see that we have expressed y as a function of x, right? So if we take y is equal to f of x, then the function is y is equal to 1 plus minus square root of 1 minus x. So we can also find out the value of y of minus 8 using this result. So taking x is equal to minus 8 over here, we have y is equal to 1 plus minus square root of 1 minus 8. So this is 1 plus minus square root of 1 plus 8. Minus times minus is plus. So here we have 1 plus minus square root of 9. So this is 1 plus minus 3. So taking the positive sign, we have 1 plus 3. Taking the negative sign, we have 1 minus 3. So this is 4 and minus 2, right? And which is the same result which we have obtained just before. So now here there is one important interesting thing, right? Now see here we have expressed y in terms of x, and we can easily see that the domain of the function y is those values of x which makes it defined. So here we have square root of 1 minus x, and this term, that is 1 minus x, must be greater than or equal to 0, right? So for y to be defined, 1 minus x should be greater than or equal to 0. So from here we can write minus x greater than or equal to minus 1. So multiplying both sides by minus 1, we have x, and here the direction of the inequality get reversed. So here we have 1, right? So the domain of the function y, which satisfies this differential equation with this condition, is x less than or equal to 1. So x less than or equal to 1 can also be expressed in terms of interval, that is x belonging to the interval that is minus infinity to 1, right? Here we have the open interval, and here we have 1, and here we have the closed interval. So here we can easily see that when x is equal to 1, we have y is equal to 1 plus minus square root of 1 minus 1. That is 1 plus minus square root of 0. So this is simply 1, right? And which is our original condition, which was already given in the question.